Welcome to module 31 of object oriented analysis and design. We have been discussing about UML diagrams. We have covered three major diagrams, the use case, the class diagram and the sequence diagram. In the current module, we will talk about communication diagram, which is also an interaction diagram like the sequence diagram, and it has a lot of relationship with the sequence diagram as well. So, we will talk about what is the communication diagram and what are the different components of that diagram. I would just like to remind you that for understanding this module well, you should be well versed with the client server computing model, which we had discussed earlier, and the communication diagrams, and just note that we are often referring to it as collaboration diagram also, because as history goes that in the UML version of 1.x somewhere in the middle, this diagram was introduced as a collaboration diagram. Later on, when modifications were made and we got into UML 2.x, currently that same diagram has been renamed as a communication diagram. So, in the community both terms are interchangeably used. So, this diagram, this collaboration or communication diagram occurs as a part of the behavioral diagrams, the interaction diagram in the analysis stage, that is where it gets generated, and then it gets refined in the design phase as well, which have we had seen this earlier. So, in the design phase it is actually bundled in terms of this particular behavioral model. So, now, so what are communication diagrams? The communication diagram is basically interaction, as the name suggests, it is saying communication diagram. So, how does objects communicate between themselves? So, looking at the client server model of basic computation is through messages. One object has to send message to another, and then the recipient object has to react to that. So, in the communication diagram, we try to check this interaction between the different objects, which are known as lifelines. The messages are sequenced, and we will see this more. What does sequencing mean? Do not get confused with when we said the sequence diagram. The sequence diagram talked about a sequencing which is strictly temporal in nature. So, we were always concerned in the sequence diagram in terms of the looking at the messages in the order in which they happen in time. In communication diagram, in contrast, we will try to look at what is seen as more in the order of space. That is, we would be more interested that if object O1 has sent a message M to object O2, then eventually when will object O2 send a message to object M3, and when object M3 will send a message to object O3 will send a message to object O4, and so on. And it is not necessary that they will be in consecutive time order, but what we are trying to see is basically what is covered by space, that is how objects actually receive and send messages, how do they communicate, and that is the basic purpose of the communication diagram. Typically, this diagram is drawn within frames which are rectangles, and at the corner you have there are two styles of naming, either you say interaction and then say the name of the diagram, or you say SD and then you say the name of the diagram. SD is little bit of a misnomer, it derives from the sequence diagram term, but this actually means a communication diagram. So, this is how you will know that this is a communication diagram here. Then we have lifelines, as we had in the sequence diagram. In you recall, this a lifeline is an instance of a object, and we had this, that it is a box within which the name of the object is given, and then we have a vertical actual line over which the object has a life. A lifeline in communication object just has a rectangle or the so called head of it. It does not have the tail. This tail part is not there. It just has the head. So, that is called the lifeline in terms of the communication diagram. In sequence diagram, you have the head as well as the tail. So, these are the typical heads that you have. We had seen this similar heads in sequence diagram. This is a anonymous instance of the user class. This is a instance name data of the stock class, and this is a collection data where we are talking about the kth lifeline of the X collection. So, these are the basic terminology. Then we have messages. Messages are shown in terms of a connection line, and you show a arrow designating who is sending a message to whom. So, this is an instance of class A, this is the instance of class B, and this is the message that is being sent. You will see that we will just next go into what does this number mean. It is called the sequence expression, and this the condition which says S1, if S1 is equal to S2, then the remove message will be sent. So, that is the basic structure of a message. Now, how the messages are sent, and in what condition what message is sent is guided by the whole of the sequence expression which you see here. So, we will now next go into the notion of sequence expression. So, the sequence expression, this is a formal definition of the sequence expression, but let us look at this. So, in the sequence expression you have two parts, one is a actual expression and the other is a name of a message, they are separated by a colon. So, this tells me what is the sequencing of the message and in what way, and this tells me what is the message. So, these are two parts, sequencing and the message separated by colon. So, this integer basically, these integers basically tell me the sequential order of the messages. So, let us look into some examples. So, in this sequential order, it is strictly integer order. So, a sequence 2 follows a sequence 1, and then in effect of 2, if you are doing a new message next, then you mark it as 2.1, which will follow the action 2. So, 5.3 will follow 5.2 in the message when the activation is for 5. 1.2.4 will follow 1.2.3 when the activation is for 1.2. So, it keeps on going like that. So, you see the messages in space, but through the sequence numbers you can relate as to what is their ordering in the time domain. So, the purpose like in sequence diagram, if you recall, we had the lifelines going like this and going like this, and basically we wrote the messages on this on an order. So, this temporal order was the important thing. Then of course, you could see the spatial one, because the different lifelines, I have one lifeline here, I have another lifeline here, and I can say that this sends a synchronous message to this lifeline. So, we could see who is sending what message to which other object, but the interest in the sequence diagram is looking into this time order. An interest in the communication diagram is to look into the spatial order, that who is sending whom, and the sequencing information is encoded in the sequence expression. So, here if we read this sequence diagram, it says that the instance of A is sending a message, draw message to instance of B, whose sequence order is 1.2, and on receiving that, B sends a message pent to an instance of C, and therefore, its sequence expression turns out to be 1.3. So, that is how by reading these sequence numbers you can figure out in which order they are happening, but the communication diagram primarily has to specify what is the spatial order, what is the object interaction order. At times you can use a name along with this number, it is typically a single alphabet. If you use that, then it means concurrent messages. So, here what is meant is there is an instance of class A, it is sending a message draw to an instance of class B, it is sending a message draw to instance of class B, and these are happening at a sequence order of 2.3. So, in this that is in the activation of 2, first 2.1 has happened, then 2.2 has happened, then in this the 2.3 A and 2.3 B, these are happening in concurrent manner. That is, between these two there is no sequential ordering, they will happen at the same time. So, this is what you specify when you write this named part along with the sequence expression. So, if I have 1 A 1 B, that means 1 V is taking place concurrently in terms of 1 A 1 B, and when both of these are over, then we will have the sequence expression 1.1. So, that is the basic. So, you first resolve without the name, and then once you have resolved without the name, then if the integer expression is same, the names mean that they are all concurrent messages that will happen. Messages can have guards. Guards are like Boolean conditions. So, here we say that this is a we say that this is a guard. So, the guard is x greater than y. So, it says that at 2.3 sequence at the concurrency B. So, there is something else which has concurrency A. If x is greater than y, then send the draw message. So, it will be executed if x is greater than y. Similarly, here is another, the sequence expression is 1.1.1. At that level, if S 1 equals S 2, then you send the remove message. So, these are the guard conditions that you can specify in terms of sending the messages. Certainly, the messages could be sent in a recursive or iterative manner. You can keep on sending number of messages to number of objects from at the same level, and when you send number of messages to number of objects, you can have two protocols again, that you could send those messages in sequential manner one after the other, or you can send the messages in concurrent manner, that is all together. Example, let us say I am saying 4.2 C. So, 4.2 C means it is at a the second activation, second message in the activation 4. It is a C concurrent thread of the execution, and in this I am saying star I 1 to 12 send the message search T I, which means that the fact if I just write this means sequential. So, it says that from 1 to 12 you keep on sending search messages. So, you first search T 1, then you send search T 2 and so on. You execute them one after the another. But in this whole thing, if I introduce two parallel bars, that means is a concurrent message, which means that all these 12 search T 1 to search T 12, all these concurrent messages will be sent together, they will be sent at the same time. In this case, they will be sent 12 times one after the other, in this case they will be sent at the same instance. So, this is how these are two different kinds of iteration, sequential or concurrent iteration that you can specify. You may not specify how many times a message will be iterated. So, it could be like just the star. So, it says that at 2.2 level the notify message will be sent to, you do not know how many. So, star means it could be 0, it could be any number of them. It will be repeated arbitrary unknown number of unspecified number of times. It may be governed by some other factor. So, this is these are examples of the iteration. For example, we have already explained this is k going from, these are n different requests being sent one after the another, there is n different requests being sent concurrently at the same time. So, let us look at an example to understand all that we have. So, just to show you, there is an annotated diagram also which I will bring up for your practice later on. So, these are the different lifelines you have, just the heads, the online bookstore, the inventory, the book, the shopping cart, the order, all the kind of different objects that we need if we want to buy some book from an online bookshop. If you look at these, you can certainly see that these are the different messages that are involved here. Just for convenience of better understanding, I have made the level 1 messages as blue and level 2 messages as red, otherwise they do not have any specific meaning in terms of UML. So, from these numbers you can figure out that certainly the first message is this, where the actor, this is actor, sends this message to the online bookshop. And what is that message? Find book. What is the nature of this message? You can see from this star that it is a repeated message. This is an iterative message. What kind of iteration? This is a sequential iteration. So, what does this message being sent from the actor to the online bookstore instance mean? To start with, it means certainly, as you can understand, that the actor is trying to find books repeatedly, one after the other. Now, but what happens once the actor has sent this to the online store? Online store in turn has to look up the inventory where the books are there, because the online store will have to see whether the book is available. So, based on one of these messages in the sequence, it will in fact for each one of these messages one by one in the sequence, it will do a 1.1, that is the next message to send, which is a search message which has to go to inventory, and then inventory will find it, not find it, whatever. Based on that, then 1.2 is, so now you try to perceive what is happening. The actor is sitting in front of the online bookstore window, is trying to find books. So, there is some specifies some keyword, some author name, something to find books which is taken by the online bookstore. Then a message is sent to the inventory for the search, and you have got a set of lists possibly, and then the question is whether you select a book depends on if it is interesting. If there are 10 books come up, you do not look at all the books. So, you do a view book of a particular book object provided you are interested. So, you model that by saying that the online bookshop sends a message to the instance of a book which is guarded by the fact that the person is interested, and that message is view book. And look at, this was 1, this was 1.1, this is 1.2. So, logically this is the next thing that will happen. If you look into this in the sequence diagram, then you will see this one first, then you will see 1.1 on the different lifelines, you will see them in this order, but here you are seeing them in the spatial order of who is talking to whom for the task. Now, certainly once this has been done, the interested book has been looked up, then in some cases the person would be interested to buy, would decide to buy. So, 1.3 is the next message, which is guarded by decided to buy, that if the book the person was interested in, if the person is deciding to buy that, if that condition gets satisfied, then the book is added to the cart. So, that you say add to cart. So, this becomes in this sequence, this becomes the next message. So, here you can clearly see that one is the overall activation of finding a book, and that has been achieved through 3 sub activations of 3 messages of search from online bookshop to inventory, view book from online bookshop to book, and finally, add to cart from online bookshop to the shopping cart. So, this kind of completes one activity, and then certainly then what will happen again, this is got a star, this is a repeated iterative process. So, this process will keep on happening every time you send this out, send the find book out. All messages may happen, not all, maybe all messages will not, this may be false, this may be false. So, in that case the message will not get sent, but in this order this will keep on happening, resulting in the shopping cart getting filled by the books that the person has decided to buy. So, what is the next activity that will happen? What is the next thing that is going to happen is marked as sequence 2, which is a checkout process. So, you say now the actor sends a checkout message to the online bookshop. The online bookshop knows that now the checkout has to happen. So, where will that checkout will happen from? Naturally from the shopping cart. So, at this level the next sequence message is 2.1, and that is to get the books from the cart. Certainly, there is no guard condition, because if you have been asked to check out, whatever there in the cart will be brought for the consideration of the person. Of course, you can refine and make some hygiene conditions as guard. For example, get books will apply provided you have some books in the shopping cart. Now, once so that you will see subsequently. So, once that has happened, then you have got the books that were there in the cart. So, this is the next message which checks if the cart is empty or not empty. Certainly, if the cart is empty, then there is no order to make. So, this message cannot be sent. But if the cart is not empty, even if it has got one book, then you will proceed to make the order, which is a message that the online bookshop will send to the instance of the order item, order class. So, once the order is ready, then there will be several others here. For example, we are not showing that. So, the order will have the process of payment and all that, authentication, all those will come up. Assuming that all that has gone through and you reach a state where the order is complete, this condition becomes true, then you have the next sequence in the activation 2 after 2.2 is 2.3, where you say if the order is complete, that is a guarded one, then you update the inventory, because now they will have to be shipped. So, this is just to show and explain to you as to how the different actions in the online bookshop can be represented in terms of messages, and how these messages are sequenced for the purpose of representation. So, this is the same diagram, only thing here is all the different items are annotated. So, you can use this diagram to clarify if you have had any doubts, and make sure that you understand the all different syntax of the communication diagram clearly. There is another example here for order management, which I have primarily included for your practice. So, you have a customer who places an order. So, that is for the order checkout part primarily, and so this is this does not have a sequence expression, which means this is what starts the whole thing. Then there is a first action, which is getting total. So, if you have to check out the order, means you have to actually start considering how much you have to pay. So, the order checkout sends a get total message to the order instance. You can see that in compared to the earlier one, this is written little differently. For example, here for every message there is a function operator notation which is used. So, these are all optional stuff, and after this has get total has happened, naturally the order object need to know what are the items that exist in the order. So, it sends after this one, it sends the next sequence is 1.1, which is get total sent to the order item, because order item need to tell what is the total, because it depends on the item. Now, the item cannot say that, it needs to, the order item cannot say that, it needs to actually go to the item in the inventory. So, it sends 1.1.1, which is getting the price depending on how many have been ordered. So, that is the parameter that you send, that these many have been ordered, and this is the next message. So, once that has happened, so this, then within this, then you go to the next stage in the processing, which is after 1.1, next stage is 1.2, that is you get the total of the order, because you have now got the price for each and every order item. So, your 1.2 is the total of the order, which the order sends to itself. So, here you can see that this is a self message kind of. We have seen self messages earlier in sequence diagram also. So, it is a self message which order sense itself to find out that what is the total of this order. So, now after having done this, you have the total of the order. So, next step would be to, so you are done with the messages starting with 1. So, next activation is 2, which is that money, the order total money has to be paid. So, you send a debit message to the credit card payment. That within that activation you have to reserve, block that with the payment processor, which is the payment gateway or something. After it has been blocked and your card details identity has been authenticated, then it has to commit, that is actually debit it from your available balance in the card. So, the commit message happening, and that will complete this part, which is debiting the order total. So, the action 1 was activation 1 was done, now activation 2 has been done. Now, what do you expect? Now, you expect that all this information will come on the display and the details of the items that you have actually purchased now through this order will be known to you. So, the third activation is a display which the order checkout again sends to the checkout page. Checkout page needs to know what the order is, sends out 3.1 to get that info to order, which in turn goes to the order item, which in turn goes to the particular item, and through this 3.1 and 3.11 you get the list of items which are displayed on the checkout page. So, this is just another kind of so all this sequencing, you can see that here dominantly you are showing what are these different lifelines which are interacting between these with these messages to achieve the different purpose that they need to serve, and at the same time you are following certain sequence expressions which show the original temporal ordering of their behavior. So, the same thing drawn in the sequence diagram would look very different, because these based on these numbers the messages will become ordered on the tail of the lifeline, and these objects will not be placed according to their interaction, but they will be placed just arbitrarily as vertical lifelines one after the other. So, this is the basic fundamental to the communication diagram. So, in this module we have introduced the communication diagram, we have made references to how closely it relates to the sequence diagram and what is their interoperability. The sequence diagram is a temporal behavioral diagram for interaction, and communication diagram is a spatial behavioral diagram for interaction, and both of them are closely related, but they define two different aspects of the dynamic behavior. We have discussed also a couple of examples, and I would encourage you to, we have not covered it in the presentation here, but I would encourage you to try to build the communication diagram for our leave management system exercise.